Welcome to the CopperSpice YouTube channel, and thanks for joining us. In this video, we are going to talk about type traits. Type traits in modern C++. Too often, when discussing type traits, rather than defining the terminology, only examples are provided, and the definition is assumed. Although we are going to start by talking about when to use a type trait and why they are of value, we are going to cover what a type trait is. We want to show a few examples and then explore the various categories of type traits, which will help to show how they are named. Then we want to talk about the difference between a user-defined policy class and a user-defined type trait.
Most discussions about type traits tend to gloss over or never even attempt to define the terminology. We really feel a definition is very important, but before we do, it seemed helpful to mention why you might want to use a type trait and talk about how your code can be improved with type traits. There is a good chance you may already be using a few type traits in your code and not even know it. One of the advantages of using a type trait is for optimization. It is awkward to have code which branches based on the data type and have your API require the user to pass in some value to help you choose the correct code to run. Your code is more efficient when you can query the data type and make certain choices behind the scenes. For example, you might want your code to do something different based on the data type being a float or a double, and reject the data if it is an int. Using a type trait is the right way to make decisions based on a data type. Type traits are very useful when writing templates. You might want to choose a particular algorithm for sorting, and if you know the data type for the iterator, you can choose between a quick sort and a merge sort and drastically change your runtime performance. Asfine is a way to indicate to the compiler you want a particular template thrown out based on the template parameters. Type traits provide a clean way to implement this by finding out if a data type has a certain property. You might be able to improve your template code if you knew the data type could be moved or copied. It might also be necessary to accept any data type in your template. However, your code may need to change a past value, and it might be const. Using type traits, you can remove the const and therefore declare a non-const local value that you can modify.
It is important to understand that type traits are resolved at compile time. A type trait can be a templated class, but it is usually implemented as a templated struct. In most cases, the base template is empty or simply provides default values. Specializations are added to override the default values. Most of the structs are pretty small and provide a single piece of information about the data type. There is no special syntax to define a type trait other than it needs to compile and work correctly. The code for a template class or struct is typically pretty simple, and the body is often just a type def. As we were starting to put this talk together, we looked at some of the history surrounding type traits and discovered the ideas have been around longer than most developers would have guessed. From our research, we found that char traits class was available in C++ 98. This trait was used in the implementation of std_string to provide a generic way to determine the length of a null-terminated string. Boost added a traits library around 2000, which greatly extended the ideas and formed the notion that a type trait should provide information about one data type. Full support for type traits was added in C++ 11, and C++ 17 added several more. Many of the standard type traits in C++ you can implement by hand. However, it's not really a good idea. The ones in the standard have been tested and work reliably. There are some you cannot implement yourself since they rely on internal information the compiler does not expose. At some point, when metaclasses are part of C++ 26 or C++ 29, then you might be able to write any type trait you want. In reality, you should only be writing a new type trait when a specific requirement exists which has not been solved by the standard.
Here are some simple examples of what you can test with a type trait. These traits return a value based on a particular data type. Notice in the first example, we are not passing a t, but rather a specific integer type, namely a long. Traits which return max and min of a particular integer type are very useful since the results are platform specific. std remove reference is another type trait which is used to remove a reference from the provided data type. If the t does not have a reference in the type, then nothing is done and the original type is returned. There is no need to test beforehand to see if there is a reference to be removed. The type trait class handles this for you. The : type is part of the syntax of using a type trait. This syntax asks, what type is this t if all references were removed from it? The left column of the table shows the original data type, and the right column shows the result of calling the remove reference type trait. The interesting one to note is where the original data type is an R-value reference and the result is simply t. This type trait does more than remove a single ampersand. It removes all reference specifiers from the data type. The type traits in C++ can be separated or grouped into various categories. We are not going to show every type trait, just a few of the most common so you can get a feel for what kind of things are contained in each category. The numeric limits type trait class has a unique syntax unlike any other type trait in the standard. Where you see the two question marks, you put the attribute to query for. The syntax for these attributes is somewhat inconsistent within numeric limits, so you will need to consult the C++ standard. Some are functions while others are static constants. One of the most common type trait categories is called the type category traits. All of these traits are queried using : value and return a boolean indicating whether the t that was passed meets the desired specification.
The type properties and supported operations categories also use the : value syntax. Some of these traits require one data type and others require two. The isConstructible trait requires a variadic parameter pack as the second data type in order to figure out if this t can be constructed from the given arguments.
The relationships type traits are useful when you want to compare two different data types and find out if they are the same type, one is the parent of the other, or if one can be converted to the other. The modifications category of type traits is a bit different, as it returns a new data type based on the past template parameter. This is why the syntax for using the modifications type traits ends in : type rather than : value. The transformation trait category consists of type traits which take one or more data types and return a different data type. The enable if type trait is mostly used when setting up a template to implement sFine. It is used in combination with one or more other type traits that determine if the template parameter is valid for the current template specialization.
In C++ 14, they added a new syntax for the type traits which return a type. In C++ 17, they added a similar syntax for type traits which return a value. In C++ 14, they added variable templates, but you could not add the inline specifier until C++ 17. Without being able to use inline, this code could not be located in a header file. It could be in a CPP, but this is essentially a file local. In C++ 17, they added the ability to mark a variable inline, so this code can be moved to a header file. The odd part is that they also, in C++ 17, expanded the definition of const expr to mean inline. So the inline keyword is actually redundant.
A policy class is something many developers have used and might not have known what they were called. The std map container takes 4 template parameters. Anyone who has used this container is aware of the first 2, as they are required. The 3rd and 4th template parameters are optional since the STL provides defaults. If you want your map to sort in some unusual way, you do not need to inherit and redesign std map. You simply define your own comparison class and pass the data type of your class as the 3rd template parameter. Your custom comparison class is called a policy class. Based on what class is receiving a particular policy class, the policy may need to contain specific members. The requirements for a policy class are well documented in the standard. It is very helpful that std map uses a policy class for comparison and not a type trait. If the comparison was a trait, you could not pass a different policy and thus override the behavior of a particular usage of map in your program.
The STL provides std regex. However, there is a limitation with this class. It does not delegate enough implementation to the policy class. With std regex, you can define a type def to specify the string type you want to use. However, this type def is required to be std basic string char type. We had a requirement in our regular expression class for the string type to be a CS string. The CS string class is part of our Unicode-aware string library used to support UTF-8, UTF-16, and other encodings. Since we could not use std regex, we copied and refactored the boost regex class. Our new basic regex class uses modern C++ to query the policy class and reduce the amount of assumptions it makes. There were many places in the old boost regex class which use pointers and not iterators. We have cleaned up this code to remove the raw pointers and support user-defined string types. The interesting part of all of this is that the regex traits is a traits class from the viewpoint of a user calling a regular expression class. Regex traits is a policy class from the viewpoint of the basic regex template. It is worth noting that the difference between a trait and a policy can sometimes come down to the way it is being used. The regex traits is a traits class since you do not pass any additional templates to the regular expression class. The flexibility of our design allows you to specialize the regex traits class and change the behavior of the regular expression class without changing your code, which instantiates the regular expression template.
For more information about CopperSpice and our other open source libraries, please visit our website at www.copperspice.com.
Thanks for watching. We hope you found the content of value. If you have any questions or feedback, please feel free to leave a comment on this video or send us a private email.
Please make sure you subscribe to our YouTube channel and come back in 2 weeks for our next video.